So in today's lesson, we're going to learn about how to predict the products of chemical reactions. And so why would we want to do that? Well, whether or not you're thinking about it, chemical reactions happen in the world all around us, right? And so scientists may want to have an idea about what to expect if they combine certain chemicals, or maybe they have a certain product in mind that they hope to design, and they need to know which reactants will be required to make that product. So in this course, we're going to talk about 5 general types of reactions. 4 of them in the first component and then 1 on its own. So we're going to start by talking about what I consider to be the simplest, which is a synthesis reaction. So in chemistry, when you synthesize something, that's another word for make, right? And so let's take a look at the reaction that is here. And so in general, we would say, sort of like in math, how we have formulas. So the formula for a synthesis reaction would be this guy. A plus B reacts to make AB. So what do we see here in this? What are some clues or cues that are going to let us know that we have a synthesis reaction here? Well, what I'm hoping you're seeing is that we have, in this case, we have an element that's combining with a different element. And, that creates a compound. Okay, so that is going to be your clue or your cue that this is a synthesis reaction. Okay, let's do some examples and then you may have a better idea about what I'm talking about here. So this year when we learn about synthesis reactions, we're always going to be looking to see whether there are 2 elements that are going to combine. So for instance, as soon as I look at this reaction here, I can see this is an element and this is an element. Aluminum and oxygen are both elements, and so that tells me that over here my product is going to be a compound. And what I have here is a synthesis reaction. So let me break down how it is that we go about this. Now, remember the formula was, it was A plus B goes to make AB, but this is a bit of a simplification. We're not just smushing these 2 guys together to go AlO2. That would be wrong. We don't want to do that. And so let me explain to you what is really meant when we talk about this general formula. So let me get rid of some of this and we'll start over. Okay, because this is one of the most common mistakes I see that students make. So we're going to have to remember the most common ionic charges for each of these elements in order to know how they will combine to form a compound and in what proportion. So I know that when aluminum joins oxygen, aluminum being a metal and oxygen being a nonmetal, that they're going to combine to form an ionic compound, right? And so in an ionic compound, these atoms suddenly become ions. Okay, and so that's important to consider. So we want to look at our periodic table to see the most common ionic charge for these particular atoms. Okay, and so when we look at aluminum, you should be able to identify that aluminum has a charge of +3 and oxygen has a charge of -2. You might be saying, well, what about this 2 down here? Well, we don't need to worry about that. That 2 is there simply because oxygen is one of our diatomic molecules and we're never going to find oxygen on its own. So it's going to exist as O2. So now that we have our common ionic charges there, we know that these are going to dictate how these elements combine in this compound. And so all we do now is our crossover rule. Same as before. And so when I cross these down, the product that I get is Al2O3. And something that I could do to practice here would be to go ahead and balance this chemical equation. If I'm asking you to predict products, I may not ask you also to balance, but it's not a terrible idea to practice. So let's go ahead and do that. So when I look at my aluminum, I can see that I have 3 oxygens and 2 oxygens over here. And so a common denominator between 2 and 3 would be 6. So I'm going to put a 3 in front of my oxygen on the reactant side and a 2 in front of my oxygen on the product side, because 2 times 3 is going to give me 6 and 3 times 2 is going to give me 6. But in the process of doing that, I've actually also altered my aluminum. And so now I have 2 times 2, or 4 aluminums. And so I'm going to go ahead and have to put a 4 in front over here. And now this is good and balanced. Okay, I'm not going to go through the balancing for all of these questions, just that one example because we want to focus on the synthesis reaction, but you should go ahead and try to do that as we go along. So for you to get the most out of this, what I'd like you to do is to pause the video and give this question a try, and then take it up when, and then resume the video when you're ready to take it up. Okay, so first of all, what am I looking at here? Well, I can tell that I have a synthesis reaction because I have an element and another element that are going to combine. Okay, and so what I need to do is I need to remember that each of these, when they form a compound over here on my as a product, that they are going to be forming ions, right, in that product. So I'm going to look on my periodic table and see that hydrogen has a charge of +1. And bromine has a charge of -1. And so when these cross over, that +1 and that -1 are just going to kind of be there as H1, Br1. But of course, we know that those ones are understood to be there just like we see in math. And so we're just going to write our product as HBr. Hopefully you did okay with that, and if you decided to balance it, then you'll know that has to be a 2 in front of here. And if you struggled with any of this, make sure that you pop into our all-day Zoom meeting to get some extra help. So here's our final example in the category of synthesis reactions. And so I want you to pause the video and give this question a try and see how you do. All right, I'm going to take this question up. Now, in ionic compounds, typically we would put the cation first. This is going to be a molecular compound, so it's, the rules around which element goes first is going to be a little different, but we are going to use the crossover rule nonetheless because this will combine in that fashion. And so let me take a look at nitrogen. So nitrogen has a charge of -3, and hydrogen has a charge of +1. And so when I cross these down, the 1's going to go beside the nitrogen, and the 3 is going to go beside the hydrogen. And so what we get as a result is we get H3N. But in chemistry, this is a pretty, well-known compound, and we actually typically write it as NH3, and this is actually ammonia. Now that is beyond the scope of this course. You don't need to know this year. So if you got H3N or NH3, then I would consider that to be a correct answer this year. And if you went ahead and you decided to try to balance it, I can see that 3 and 2 are common denominators. So I'm going to put a 2 here and a 3 here. That changes the number of nitrogens to 2 times 1, which is 2, and I've got that balance. So now this, oops, I'm going to need to fix that and put my 2 here, and now I am good to go. All right. So now what I want you to do is pause this video and go to the week plan and locate the worksheet on synthesis reactions and work through that before continuing on to watch the next video on decomposition reactions.